Hi guys, in this video I want to go through this LeetCode number 94, binary tree in order traversal. So the key to remember this is the order we show the value is from the left and then the root and then to the right. So as you can see in the example here, so the left is nothing, that's why it goes to the root and then to the right and then to the left, to the root and to the right. Sorry, so let me say again. So from the left is nothing to the root, and then go to the right, and then from this right branch, go to the left first to the root. That's why it goes 1, 3, and 2. And for this is a trivial case, and this from the left to the root. That's why it's 2 and 1. And the left is nothing, and then to the root and to the right. So it's go to the root and the right because the left is nothing. So this is the second method among the three depth first search methods. So as you can see, left and the root and the right. So there's an pseudocode in here, and we will implement together later. So we can solve this problem by using two approaches. One is the recursion method. Another one is the iterative for loop method. So let's follow the recursion method first and to build up some intuition. And after that, we can do the iterative method. So if root equals to none, so it's always the boundary case that we want to deal with. That's why we put it first. So in that case, we return a empty list. And otherwise, if the root is not none, and we will return root dot concatenate. Sorry, it should be so this should be in the middle because it's the root. And root dot left, and then concatenate, and then the value itself, and then root dot right. So this should work. Let's see. Should be calling the function. So sorry about that. Recursively calling the function. So that's how we do it. Oops. Let me pause the video. Pause the recording to see what's going on. Oh, it should be right. Yeah, now it works. So we pass all the test cases and it works. So this is the first method. We used the recursion method, and this is very intuitive, and also but some interviewer very straightforward and intuitive and very fast method. But some interviewer might ask to do it in the iterative method, and now we can implement it together. So to make it more intuitive, I drew a little diagram in here, a little tree in here. As you can see, if we use this Inorder traversal, and the first one is the most left one will be the 4, and then go to the root, which is 2, 5, go to the root again, and then go to the right branch, which is 6, 3, and 7. And this is the approach that we can solve it iteratively. So first, if it's a trivial case, if the root is none, and we return an empty list, and then we need to answer list and also stack. This is how we solve use the DFS. So and then we have the temporary, and then we capture the root at the beginning, I will walk through how this works with an example. So while root, the root is now is temporary. Also the root now is the 1. While root, and then we do this. Basically, what this does is, if we do the pseudocode, we basically collecting. So I just implementing here based on this pseudocode in here. So basically, we are collecting everything from the left, and then we pop off the nodes from the stack. We pop it from the stack, and that becomes the new root. And then we collecting that value, and then we assign the temporary to be the root to the left, to the right. So let me walk through the numerical example with you. And the first one, the node will be 1. And so also the temporary equals to node. So the stack, and then we append the temporary node, which is 1. And then we append everything on the left because we have this while loop. So the stack will become 1, 2, and 4. Right, it's everything on the left. And then we finish it because now the left node of 4 is a none. That's why we exit from this while loop. And we don't really worry about this for now because the stack is now empty. It's 1, 2, and 4. And the root is equal to the stack.pop. So now the root is equal to 4, and then it pops up, and then we append the root dot value. So let's say this is the answer, and then now it's a 4, and then temporary equals to root dot right. So in this case, now the temp is equal to the root dot right, which is a none because it has nothing on the right. And then we go back to the while loop, and the while loop, and the loop is 4, and then the temporary is none because temporary is none. So we don't do anything in this while loop, and then we take on the next one, which is the 2 from the stack, right? So the root will be become 2, and then we move the 2 from the stack, and then we collect the value. So that's going to be 2, and then the temporary becomes the root dot right. So the temporary becomes this one. This is the root right now, and root dot right will be 5. So the temporary will be 5, and while root. So while there's something now is 2, the temporary is not none because the temporary around is 5. We append the temporary to the stack, which is 5, and then but it has nothing on the left of this 5. And then root dot stack dot pop. So the root becomes 5 because it pops up from the stack. And then we are appending that value. So it's 5. And then the temporary right now is the root dot right 5. The right of the 5 has nothing. That's why the temporary is nothing. And while there's a root, which is 5, and then the temporary is nothing. That's why we don't do nothing in here. And then if the stack equals to empty, right? This case again, we don't need to worry about it for now because there's already something in the stack until the end. So and then the root dot equals to stack dot pop. So the root becomes 1, and stack is empty now. And then we appending that value, so it's 1. And then temporary equals to root dot right, and root dot right is 3. So temporary now becomes 3. And then root right now is 1, temporary is 3. So we are appending everything on the left of the 3, which is 6. So right now the stack will be 6. and then the new root will be 6. Yes, so the new root will be 6. And then the temporary right now would be root.right, which is none. And then the root is 6. And then the temporary right now is none, so we don't do this while loop. And then the root equals to the stack, so 6 pops up. So we're collecting the 6. And then root.right, 6, the right is nothing. Sorry, that somehow messed up on the right branch, but we follow this logic and we can collect all the values in here. And then at the end, when we enter, when the stack becomes empty, and then we will break out from this while loop. Oh, I think where I messed up was I forgot to append the 3. So it should be 3 and then 6. Yes, so 3 and 6. And then the stack pops up will be 6. And it's none, appending the 6. And then now this comes out. The temp and the root will be 3. The temp will be 7. Yep, because of this. The temp will be 7. And then while there's something on the root, which is 3 in this case. Yes. So 3 in this case, and then the temp is 7. And then go to here, and then the temp will be none. Yeah, the root will be and then at the end we will append the 7, and then we will come off this entire while loop because the stack will be empty at that point. And we submit it, and it runs. And so this is solution. In terms of time complexity, as we can see, it equals the number of nodes, big of number of nodes with the while loop. Keep stacking. So the space complexity will be the stack. So it's also a big O, as you can see here. So we have the same time complexity and space complexity for this stacking approach, iterating method using stack. So this is we just implemented. And for the recursion approach, the time complexity will be O of n because the recursion function we just is t of n, and because this formula over here. And for space complexity, the worst case is big O of n, and average is big O of log of n. And I think this is due to the tree is balanced or not. So the worst case is if the tree is entirely not balanced, and it will be big O of n. If the tree is balanced, it's big O of log of n. So so this is my solution to this problem. I hope you like it, and hopefully I will see you in the next video.